All right, hey, before we look at this lesson, let me just go through and make sure we're on the same page for our schedule for this week. And you can see all this in Canvas, but today you're doing a review on arithmetic sequences, and I'm going to talk about that in this video. Tomorrow you'll look at 6.6, which, remember, arithmetic is adding and subtracting. Geometric means we are multiplying. And then you're going to have a review. And then you're going to take the 6.4 to 6.6 quiz on Friday. Okay, so that's our plan. Let's take a look for a few minutes at an arithmetic sequence. Now remember that a sequence just means that we have a list of numbered, an ordered list of numbers. Arithmetic means that we are either adding or subtracting in that list, okay? So they had a couple of specific ideas that came with a list of numbers where we're adding or subtracting, where there's a pattern where we're adding or subtracting. One idea is that these lists are made up of terms. This would be considered the first term, second term, third term, fourth term, and so on. So we're going to have times where they give us the first term, and then the common difference. Difference usually means subtract, but when we're referring to the common difference, that's just saying the distance between. This is positive, so we're adding. So if the first term is 2 and the common difference was 5, it means that we would be adding 5. 2 plus 5 would give me 7. Adding 5 would give me 12, 17, 22, and so on with that pattern. So again, first term just means here's the number you're starting with. Common difference just means here's how things are changing. Now, we also looked at an equation for the nth term, meaning I could tell you find the 150th term. You could plug it into the equation and find out what the value is for the 150th term. The equation that we looked at was a sub n equals a sub 1 plus n minus 1 times d. Remember, this a sub 1 is just our first term, and d was the common difference. N would be where we plug in the 150. N is like x. A sub n just means we're looking for the value of some term, like y. Okay? So if they give us this pattern, and they said to write an equation, we'd say, all right, a sub n equals my first term, which is 3, plus n minus 1, times my common difference. Well, how are these changing? I can see that we are adding 10 every time. So for D, I'd put 10. If I had a hard time finding my common difference, I can always do my second term minus my first term, and that will give me the common difference. Now, I would take your answer like this. We also talked about how you are able to distribute this 10. And then you could write your answer in what looks like slope-intercept form. 10n, negative 10 plus 3 is negative 7. So again, I would take your answer looking like this. That follows our formula. You also could distribute the 10 and write it in what looks like slope-intercept form for us. The last thing I just want to touch base on that we might see a little bit today, but we'll definitely see later, is if it says write a recursive rule. This word recursive, this up here would be an equation for the nth term, or this would be an explicit rule. What I want to show you, and this is my last thing, is how we would write a recursive rule. So let's say we have that same pattern, 3, 13, 23, 33, and so on. A recursive rule always follows this format. We state our first term, and then we say, here's how we get our second term, or all the ones following it. Well, we state our first term. Okay, my first term is 3. And then in this line, we say, how do we get the next ones? Well, we have to take the previous. So that would mean a sub n minus 1. That's how we say take the previous term. And we would add 10 to it. this right here would be considered a recursive rule. Let me show you one more example. Let's say I gave you the recursive rule. Let's say I have a first term of 1, and then to find the next term, I take the previous, and I subtract 4. If I had to list the first 3 terms here, I'd say, okay, I start with 1. In order to find the next term, I go back 1. This is what a sub n minus 1 means. Go back 1 and subtract 4. So this would then be negative 3. To find this term, I need to go back 1. That's what a sub n minus 1 means, and subtract 4. So that would put me at negative 7. To find this term, go back 1, a sub n minus 1, and then subtract 4. That would be negative 11. So again, here this would be giving, this is the recursive rule, and this would be listing terms based on that recursive rule. So under an arithmetic sequence, which means adding or subtracting, we have an explicit rule, and this is a sub n equals a sub n minus 1 plus n minus 1 times d. We also have now what's called a recursive rule. And that's when we give the first term, say, okay, here's how we find the second term. We do a sub n minus 1, then it's either plus or minus whatever our common difference is. All right, so those are the couple things we're going to be mostly reviewing here today.